Now we're going to talk a bit about orthogonal vectors. Two non-zero vectors, u and v, can be considered perpendicular if the angle between them is pi/2 radians or 90 degrees. And in all of those situations, we will have u dot v equal to 0. The reason that is because that we know the cosine of pi/2 is 0. So orthogonal basically just means perpendicular, and what we know is that the dot product of u dot v, if that's equal to 0, we can say those vectors are orthogonal or perpendicular. So let's determine if two vectors are orthogonal. Here we're asked to find, are the two vectors orthogonal? We are given the vector u, which equals 3i minus 2j plus k, and v equals 2j plus 4k. So this is the same as u equals 3, negative 2, 1, and v equals 0, 2, 4. So the dot product, u dot v, equals 3 times 0 plus negative 2 times positive 2 plus 1 times 4. Simplifying that, we have 0 minus 4 plus 4, which is 0. So because the dot product of these two vectors is 0, we know that these two vectors are orthogonal, or rather they lie at a 90-degree angle from each other. So now that we've used the dot product quite a bit, and we've used the dot product to find the angle between two vectors as well as to show if vectors are orthogonal or perpendicular, let's talk about properties of the dot product. Right, so these are algebraic properties. If we have three vectors, u, v, and w, all these lowercase bold letters represent vectors. C represents a scalar. U dot v is equal to v dot u. The dot product is commutative. Constant times u dot v is equal to u times that same constant, or u dot, the same constant times v, I should say, is equal to that constant in front of u dot v. So this is a little bit of the commutative and or associative property. We can put that C with either term in the dot product or in front of the dot product. Property 3 here just lets us see how the dot product is distributive. U dot v plus w is the same as u dot v plus u dot w. Number 4, a vector dotted with itself is always going to equal the magnitude of that vector squared. And number 5, the dot product of the 0 vector times any vector u, dot any vector u, is equal to the scalar of 0. Notice this is a scalar because it's not bold. And these can all be proved using basic algebra. I would refer you to your textbook. I know that we prove 1 and 3 in there, but I'm not going to spend time proving these for you right now. I'm just going to ask you to believe me that they are true. And we're going to move along talking about vector projection, projecting a vector onto another. So in this video, we just talked about orthogonal vectors and then some properties of dot product.